All right. Hey everyone. My name is Simon Tran. I am an ASU student and I'm studying applied mathematics. I took Mrs. Rodriguez class last year, so I have some experience with AP Calculus and the exam itself. So today I want to go over limits and derivatives. So I have some problems here from the review. Uh, and I'm gonna go over the odd questions, and the even questions will be for you guys to practice. So we're gonna get started on number one, and you can pause this and try it out before seeing the answer. So for number one, we have the limit as theta approaches 0 of 1 minus cosine of theta all over 2 times sine square of theta. So the first thing you want to do with this problem is always substitute the value in for uh, theta, right? So we have 0, and we're going to substitute that into the function. So we have the limit as theta approaches 0, the function 1 minus cosine of theta all over 2 times sine square of theta. So when we plug in 0, we will get 1 minus cosine of 0 all over 2 times sine square of 0. And cosine of 0 is just 1. So 1 minus 1 is 0. And then all over sine of 0, which is 0, square that is 0. And then times 2 is also 0. So we have 0 over 0. And that is an example of an indeterminate form. So whenever we have an indeterminate form, we would need to use L'Hopital's rule. We use L'Hopital's rule when we have 0 over 0, or if we have infinity over infinity, we would use, but you won't see much of that. You'll see a lot of 0 over 0 type questions, or type answers. So let me get rid of that. So when we have 0 over 0, we would need to use L'Hopital's rule. So we're going to say, by L'Hopital's rule, we need to take the derivative of the numerator and the denominator, but we have to do it separately. So don't like use the quotient rule, and that's not what L'Hopital's rule is. So we would say the limit as theta approaches 0, right? And so the derivative of the numerator is sine of theta, because the derivative of cosine is negative sine, and we also need to remember there's a negative in front of that cosine, so that will cancel out the negative sign, and we will have sine of theta, and it will be over 2 times sine square of theta. We can rewrite 2 times sine square of theta as this to make it easier for you guys to see. 2 times sine of theta and then square. Right? We would have to use chain rule for this problem, or for this this case right here. So we're gonna bring the 2 down. So it'll be 2 times 2, which is 4. And we're gonna leave the inside alone, which is sine of theta, and then multiply that by the derivative of the inside, which is cosine of theta. So now we have the limit as theta approaches 0 of sine of theta over 4 times sine of theta times cosine of theta. So now we can cancel out the sine of theta, and we will be left with the limit as theta approaches 0 of 1 over 4 times cosine of theta. And now when we plug that in, we will get 1 over 4 times cosine of 0. And then cosine of 0 is 1, so our answer is 1/4. So C. So the important thing about this question is, what do you do when you get 0 over 0? That's when we have to use L'Hopital's rule. So you gotta know what L'Hopital's rule is and how to use it. Use the method to get your final answer. Number 3, we have y is equal to cosine square of 3x, and we need to find the derivative of that function. So first thing, I'm gonna write down the function. We have y is equal to cosine square of 3x, and you can rewrite that as cosine of 3x and then square. Right, rewrite it as that, and that makes it easier to see. And now we need to find the derivative, so y prime, or you can do dy over dx. And now we're going to bring the 2 to the front, so 2 times cosine of 3x, and then 2 minus 1, obviously that is just 1, and then times the derivative of inside, so which is negative sine of 3x, and then take the derivative of the inside again, so we're using chain rule twice, and then the derivative of 3x is just 3. And so our final answer is y prime is equal to, and we're going to bring the negative to the front and the 3 to the front. So it'll be negative 3 times 2, negative 6, times cosine of 3x times sine of 3x. So looking at our answer choices, it would be A. So this one, you use chain rule twice, and that's how you get A. Okay, number 5, we have the limit as x approaches infinity, positive infinity, of 4x squared minus 3x plus 2, all over 5x minus 3x squared plus 1. For this problem, I'm going to rewrite it as the limit as x approaches infinity, or positive infinity, of 4x squared minus 3x plus 2 and I'm going to bring the negative 3x squared to the front, or I'm going to put that first. Negative 3x squared plus 5x plus 1. So the most important thing about this question is, what do you do when you have a limit as x approaches infinity? For this one, you have to look at the highest degree in the numerator and in the denominator. So the highest degree in the numerator is 2, and the highest degree in the denominator is also 2. So what happens when we have the same highest degree in the numerator and the denominator? We would take the ratio of the leading coefficient, which is just 4 over negative 3, and that would be our answer. And what happens if the highest degree in the numerator is greater than the highest degree in the denominator? Well, that would be, our limit would be either positive infinity or negative infinity, depending on the function, or depending on the degree in and the coefficient of the leading terms of the polynomial. It just depends on the function itself. But for this case, we have 2 of the same highest degree in the numerator and denominator. And what happens if the highest degree in the numerator is less than the highest degree in the denominator? That would be 0. The limit would be 0. So just things you gotta remember. All right, number 7, we have the limit as h approaches 0 of tangent of 3 times x plus h, and then minus tangent of 3x all over h. This is the definition of derivative of the derivative. So for this problem, you can obviously, distribute the 3. All right, you can do all that. But for the sake of time and also on the AP exam, I mean, doing doing this method, the process will be long, and for the sake of time, we can figure out what our function is and just take the derivative of that function. So our function would just be tangent of 3x. All right, and then we just need to take the derivative of that function. So the derivative of tangent is secant square, and then we're going to leave the 3x alone, times the derivative of the inside, which is just 3. Right, and so our final answer is 3 secant square of 3x. So that would be B. All right, number 9, we have f of x is equal to x minus 1 squared times sine of x. And so we need to find what the derivative of that function is at x is equal to 0. So first thing we're going to need to do is to find the derivative of that function. So we have f of x is equal to x minus 1 squared times sine of x. So to take the derivative of that function, we need to use the product rule. So, and I'll show you what the product rule is. It's on the screen. So using the product rule, I'm going to first take the derivative of x minus 1 squared. So I'm going to bring the 2 down. 2 times x minus 1, and it'll be to the power of 1. And then times the inside, which is just 1, so we don't have to include that. And then we're going to leave the sine of x alone. So times sine of x plus, we're going to leave the x minus 1 square alone. So it'll be x minus 1 square. And then times the derivative of sine, which is cosine of x. So that's our derivative. So now we need to find what the derivative of that function is at x is equal to 0. So f prime of 0 is 2 times 0 minus 1 times sine of 0 plus 0 minus 1 squared times cosine of 0. So f prime of 0 would just be, let's see, that would be negative 2 times sine of 0 is just 0 plus, and then 0 minus 1, and then square that, that will be 1 times cosine of 0 is 1, so it'll be 1 times 1, and negative 2 times 0, that will be 0, so we can cancel that. 1 times 1 is 1, so our answer is D1.